All right, this is Algebra 1B Part 1, Unit 2, Lesson 4. We're going to look at some multiplication properties of exponents. Particularly, we're going to look at two rules. One I call the power of powers. Power of powers. Sounds like something from Power Rangers, you know. Power of powers! Yeah. Basically what it is a power raised to a power. So that is to say it's something like this, 4 to the second, all raised to the third. 4 to the second to the third. Now, to explain this, I'm going to write it in expanded form, and then I'm going to shorten it. We're gonna learn the shortcut because you don't want to have to expand it all the time. Okay. You already learned that if you raise a multiply of same basis, like you have 2 to the third times 2 to the fourth, that's the same as 2 to the 3 plus 4, or 2 to the 7th. Okay? And we expanded that, 2 to the third. We expanded the 2 to the fourth. 2 to the fourth is 2 times 2 times 2 times 2. We count the 2's. There are 7 2's. Right? So expanded form is the logic we use to explain it. So we're going to do much the same thing here. I'm going to start from the outside and work our way in. The 3 tells me to multiply the base, which is the parentheses, 3 times. Okay, so I'm going to expand this by writing parentheses, 4 to the second, parentheses, 4 to the second, parentheses, 4 to the second. 3 times, 4 to the second times 4 to the second times 4 to the second. Now I'm going to write out what each of those mean. That means parentheses, 4 times 4, 4 times 4, 4 times 4. Okay, now just like we did before, let's count the 4's. There are 1, 2, 3, 4, 5, 6 4's. Okay, now the task comes to simplifying. So coming up with a shorter way to do the same problem. How did 2 and 3 make 6? Now, if you think 2 plus 3, then that would be 5, so that wouldn't be it. But you're correct if you deduce that it is multiplication. Multiply. So for a power of powers, you multiply the exponents. In rule form, it looks like this. A to the n raised to the m is a to the n times m. Don't confuse that with a to the n times a to the m is a to the n plus m, which is called the product of powers rule, right? This is called the power of powers rule. So we have one base raised to a power twice, right? And so let's just practice it real quick a couple of times. So if I have 4 to the 5th to the 8th, that's 4 to the 5 times 8, or 4 to the 40th. And it can work for negative exponents. If I have 3 to the negative 2nd to the negative 3rd, that is 3 to the negative 2 times negative 3. A negative times a negative is a positive. That's 3 to the 6th. Okay, so that's how you use a power of powers. All right, the second rule I want to show you is called the power of a product. Okay, the power of a product. Power of a product. So we're going to raise a product. The product is a multiplication problem. That's a fancy word that says multiply. So a product is the answer, or a multiplication problem. And the power of a product is when you have something like this. You have 2 times 3 to the third power. Okay, again, let's write it in expanded form, and then we'll rearrange it here a little bit and shorten the process. Okay, remember an exponent works on what it touches. So this 3 touches the parentheses. So I'm going to write the parentheses 3 times. So parentheses times parentheses times parentheses. And in the parentheses goes 2 times 3. 2 times 3. 2 times 3. Okay? And now what we recognize, hopefully, is that you can multiply in any order you like, right? So we could multiply all the 2's together. There's a 2, a 2, and a 2. And there's a 3, and a 3. So 1, 2, 3 2's, 1, 2, 3 3's, right? And we can rewrite that with exponents as 2 to the third times 3 to the third. Okay? So notice what happens here. what happens here. It kind of reminds me of the distributive property. You remember the distributive property? The distributive property says this. It says if you have like 2 times 3 plus 5, that's the same as 2 times 3 plus 2 times 5. That is, the 2 gets multiplied by the 3 and the 5. Well, this is very similar. The 3 exponent goes to the 2 and the 3 both. So it goes to the 2 and the 3. It gets distributed, but it gets distributed to factors. Now, here's a point where you can get confused. Don't do this. Don't do this. Don't do 4 plus 3 to the second is 4 to the second plus 3 to the second. Okay, that doesn't work, because you distribute the exponent only over things that are multiplied, over a product, not a sum. This is a sum. It doesn't work over addition. It works over multiplication. Okay, it actually also works over division as well. So let me show you that here. So if I have 4 and 5, 4/5, and I raise it to the power of 3, that is the same as 4 to the power of 3 over 5 to the power of 3. The exponent 3 goes to the 4 and to the 5 both. Okay? It goes to the 4 and to the 5 both. All right? And if you want verification, we can write this in expanded form. 4/5 times 4/5 times 4/5. And how do you multiply fractions? You multiply straight across. This is 4 times 4 times 4 over 5 times 5 times 5, which is 4 to the third over 5 to the third. So it even works over a division, so we can expand this to a power of a quotient as well. Now, you're going to have some problems where you combine the power of a product and the power of powers rule. Okay? And let's do one of those. Okay, here we go. Do one of those. So let's say we've got 3 to the power of 2 times 4 to the power of 3, all to the 5th power. All to the 5th power. Okay, we can apply the power of a product rule this way. The 5 gets distributed to all factors inside. And so I can rewrite this way. I can write this as 3 to the power of 2 to the power of 5 times 4 to the power of 3 to the power of 5, right? The 5th power goes to the 3 squared and the 4 cubed both. And now use the product of powers rule, or the power of powers rule, which is you multiply the exponents, 2 times 5 and 3 times 5. So this simplifies to 3 to the 10th times 4 to the 15th. Now, generally, we do this in a single step. Okay? We note that we distribute the 5. 3 to the power of 2 to the power of 5 is 3 to the 2 times 5, or 3 to the 10th. 4 to the power of 3 to the power of 5 is 4 to the 3 times 5 power, 4 to the 15th. Okay? Let's try one more, and then we'll call it good. Okay? And you can practice some more in the lesson. Let's say I've got 4x squared to the power of 3. Okay? The 3 goes to the 4 and to the x squared. And to the x squared. And I'm going to do this in a single step. 4 to the 3rd power. X to the 2nd power to the 3rd power. That's a power of powers. X to the 2nd to the 3rd is x to the 2 times 3, or x to the 6th. Okay, and we can simplify 4 to the 3rd power is 4 times 4 is 16 times 4 is 64, x to the 6th. Okay, so that's how you apply the product of powers and not the product of powers, the power of a power and the power of a product to the same problem. Okay, and combine that with product of powers too. So we'll have all of that mixed up. All right, hopefully that helps.